get response from you in order to avoid technical issues. So if there's a technical issues from my side, please inform me as soon as possible through the WhatsApp. Okay. Sometimes uh, there will be technical issues. Sometimes maybe I will be disconnected from the Google Meet. Okay. And if that happen, or if there's any technical issues, please inform me. Okay. And from time to time, I will also ask your presence, whether you are still here or you are somewhere else. Okay. Sometimes it feels weird to talk to the screen by myself. Okay. I like students to ask questions. Okay. So don't worry to ask questions. There's nothing like a stupid questions or whatever. Okay. Questions will be answered with a good answer. Okay. So if I don't know the answer, I will give the answer later. Okay. If I know the answer, I will give you directly on this classroom session. Okay, so I will start sharing my screen. Okay, I will share my screen. Okay. Okay, can I get your response? Can you see my PowerPoint slide?
Yes, Doctor.
Okay, thank you
Yes.
for the response. Okay, so last Saturday, on the 22nd of March, we have stopped until this PowerPoint slide about the multiplexing. Okay, so for your information, the communication system always consists of many inputs, and we might also have many outputs. And the medium or the channel is limited to certain capacity. So that's why we need to come out with a sharing method, okay, to share the medium or to share the channel, okay, so that we can fully utilize the limited space of the channel or medium with many users. Okay, so uh, so the term multiplexing means that we are combined and we share the medium, okay, with other inputs or other users. Okay, and for this slide, if you see from here, multiplexing means that we combine many inputs. Okay, so we have many input signal that want to be transmitted across the channel. We combine it through the process of multiplexing. Okay, so once we combine it, then we can send all the inputs simultaneously across the medium. Okay, so you see that the medium here, we only have a single wire or single cable like this. So that means all of the inputs are sharing the same medium or the same channel. Okay, so once the signal arrives at the receiver, then we might need to distract. Okay, we might need to extract the received signal into many outputs. Okay, so all of these outputs will go to the different receivers. Okay, so you see that we can share the medium through multiplexing. So this is the easiest method for combining of many input signals. Okay, and later you're going to see that there are many types of combining methods. Okay, multiplexing methods of signals that we want to send through the medium. Okay, so we go to the next topic, frequency division multiplexing. Okay, frequency division multiplexing. That means we multiplex a few frequency spectrum, okay, uh, to share the medium. Okay, so multiple signal share the common bandwidth of a single communication channel. Okay, useful bandwidth of medium exceed required bandwidth of channel. Each signal occupies separate portion of the bandwidth. Okay, each signal modulates a different subcarrier frequency. So if you see from here, the picture from this FDM. So FDM, for your information, is also called as the first generation of communication system. Okay, 1G. So this is actually 1G. Okay, we have 2G, 3G, 4G, 5G, and later we're gonna have 6G. So this is the first technology used in the telephone system, in the communication system. And if you see from here, for FDM, for FDM, for example, like this. So I want to change this picture into this picture. I want to try to simplify it. So let's say that we have uh, frequency over here. So and then the time over here. Okay. And for example, if we have a bandwidth of frequency spectrum that we use for communication between one place to another, okay? So these are the bandwidth of our frequency spectrum, okay? And this bandwidth, when we want to use the communication system, we are sharing with many users, okay? Many users. So each user, we will allocate with a portion of frequency band. For example, okay, I have here is band number one, okay, and then band number one for user one, band number two for user two, okay, and then the next three and so on, okay. And maybe I forgot this one. Wait, sorry. So I will make it like this. So I will allocate uh, the first spectrum, okay, to the first user, and then I have a gap over here, and then I will allocate the next frequency slot, okay, to another user, band number two, and then I have another gap, and then I will allocate the next frequency band to another user, okay. So you see that if we have a big bandwidth, we will uh, split the bandwidth into a number of users. So each user will have its own frequency band for transmit and receive signal. Okay, so if you see from here, each user will be able to use the frequency band. Okay, each frequency band. Okay, each user is allowed to use the frequency slot for the whole time. Okay, means that, for example, this is my frequency number one is for me, for example. I can use this frequency slot for 24 hours, okay, 7 days a week. Okay, so this frequency belong to me. And the next frequency band, okay, frequency number two, is allocated to my friend, for example, Ali, for example. So Ali will be allocated frequency band number two, and he can use the frequency band for 24 hours, 7 days a week. And the next user number three, and the next user number four, and so on. Okay, so you see that FDM will give the frequency slot to each user or each radio station for them to use for the whole entire time. Okay, for the entire time, all days, 7 days a week. Okay, so that means that frequency slot belongs to each user. Okay, at all time. And each frequency slot is separated by a guard band. So guard band is actually to separate one frequency band to another frequency band. It is used to avoid the adjacent channel interference. So that's why we have a small gap, okay, to avoid interference from the adjacent channel. Okay, and you see that if we only use okay, and if you see from here, each user only be able to use a small portion of frequency, okay, for the entire time. You see that one of the disadvantages is that we can only use a small portion of frequency for the entire time. Means that if we use a small frequency band, that means our speed of transmission is limited. Okay, remember as I said on last Saturday that the bandwidth is actually proportional. Okay, the bandwidth is actually proportional to the data rate. The data rate is actually the speed of transmission. Okay, so the bigger the bandwidth, the higher would be the speed of transmission. So in this case, if each user receive a small portion of the bandwidth, that means the speed of transmission is limited. Okay, so that's one of the drawback if we allocate a specific frequency for each user. Okay, so this is for the first generation of telephone system. Then if you see from here, yeah, so FDM is also a part of multiplexing. Okay, it's also a part of multiplexing. So you see that we are sharing, okay, we are sharing the bandwidth of communication system with many users or with many radio stations applications. Okay, and if we see the next type of multiplexing, okay, the next type of multiplexing is what we call as time division multiplex. Okay, so now we are divided the time and not the frequency. Okay, so this TDM is the next technology used for the 2G communication system. Okay, and if you see from here, okay, frequency versus time. Okay, so we are dividing the time into into different time slot. Okay, time slot 1, time slot 2, time slot 3, and user will be allocated with the time slot, okay, with the available time slot when the user wants to transmit signal. Okay, so it means that if I want to transmit signal at that particular time, I can use any available time slot to transmit my signal. Okay, the next user can also transmit his or her signal using the available time slot. Okay, so whenever there's a empty time slot, user can send the signal. User can also receive the signal using the available time slot. Okay, and the good thing about this is that we can use the entire frequency bandwidth. Okay, we can use the entire frequency bandwidth, but only for a small portion of time. Okay, so if you see from here, if I want to send my signal, I can use the whole frequency spectrum. Okay, another person can also use the entire frequency spectrum during transmission and received. Okay, so you see that in this case, I can fully utilize, okay, the bandwidth. Okay, I can fully utilize, I can use all the available bandwidth for my transmission. So that means the bandwidth that I can use is much bigger. And for that reason, the data rate of the or the speed of transmission that I can achieve would also be higher compared to the FDM. Okay, so if we see from here, um, the bandwidth can be used for the entire, we can use the entire bandwidth. Each user can use the entire bandwidth. And for this reason, we can accommodate large number of users. Okay, in terms of number of users, we can use we can allocate for many users. Okay, because not all people transmit frequency 24/7. Okay, if you see from the previous one, okay, that means even though you are not using the bandwidth is still belong to you. Okay, even though I'm not using my frequency slot, okay, the frequency slot will be empty and not used. That means it is underutilized for the FDM. Okay, FDM, once you give the frequency slot to user, that user owns the frequency slot even though the user not using it. So that means it is going to be a waste. Okay, because we are not sending signal 24/7. Okay, sometimes we use, sometimes we are not using the frequency band. Okay, so that's why we come up with TDM. Okay, TDM um, avoid underutilized spectrum. Okay, so that's why we can sharing the frequency band, okay, with other users. So that means we can increase the number of users for the TDM. Okay, so that's the good thing about TDM compared to the FDM. Okay, and if we move to the third G, so the 3G is not given in this slide. So 3G system, how is it looks like? Okay, we know the frequency, we know the time, and for your information, for the 3G, for the 3G system has the third dimension. So we have uh, F versus time, okay, right, for the TDM. And for the third generation, we have the third axis, what we call as the code. Okay, the code axis. Okay, so this is what we call as the CDMA. Okay, code division multiple access. Okay, means that we have another axis over here for the code. Okay, so different frequency at different time will be given a specific code. Okay, for this, what we call as a CDMA, so this is the fundamental of 3G. Okay, when we move to the 4G, it is also based on the CDMA, but it is called as a wideband CDMA. Then as we move to the 5G, okay, 5G new radio, so it is also based on the WCDMA technology, okay, where we have separate axis, okay, for the frequency, for the time, for the code, and also for the space. Okay, so there are multiple parameters to accommodate the large number of users and also to accommodate the higher speed of transmission. Okay, and then we are moving to the 6G in the next few years. Okay, so what's the good thing about 6G? Okay, if you see from first G, second G, third G, 4G until 5G, normally we want to increase the speed of transmission. Okay, that's the first one. And the second one, we want to accommodate large number of users. Okay, and we want also to accommodate large number of uh, large number of applications. Okay, from 1G until 5G. So for the 6G, how does it looks like? Okay, so the 6G would will integrate the artificial intelligence, okay, into the communication system. Okay, so that's why the terms that we use for the 6G is the advance of AI. Okay, AI will be integrated in the communication system, and the communication system uh, will have its own intelligence to manage the communication system within the networks. Okay, and it can support a variety of many equipments, many users connected together. Okay, so that's why we are not using the terms Internet of Things anymore. Okay, it is Internet of everything. Okay, Internet of everything. It supports the connections of many things. Okay, many applications throughout the communication system. So the next communication system is more advanced, more intelligence, and support variety a lot of users and applications. That's the 6G. Okay, so even the 5G is very fast, right? If you have a 5G phone, and you see how fast would be the download time, the upload time. So at a certain places, 5G is very fast. Even though Batu Pahat also we have the 5G network now. Okay, and the speed is good. As far as I know that if you go to the city of Batu Pahat, you can reach up to 500 megabit per second at least for the download speed. Okay, and if you go to a big city like Kuala Lumpur or Johor Bahru, the speed of upload and download rate would be much higher. Okay, so that's the different technologies of communication systems. Okay, and this is as I said that this is for the TDM, so it's consists of many time slot, and user are using the available time slot whenever he or she wants to transmit and receive signal. Okay. Okay, so the next part would be the important topic, which is about the gain. Okay, so class gain would be the will come out in your test and also in the final exam. Okay, so this is very important. Okay, so please pay attention. So if you see from here, gain. Okay, gain means increment. Okay, gain means increment. And what is the increment that we want to analyze? Okay, so basically our communication system consists of input. Okay, so for example, we have a device. So each device should have at least one input and one output. Okay, so what we want to analyze is actually the difference, the ratio of output and also the input. Okay, so in this case, we want to analyze in terms of voltage or power, for example. Okay, so we can also analyze in terms of current. Okay, and if you see from here, the parameter of gain is given as A for gain. Okay, so this is based on the Wayne Thomas's book. Okay, Wayne Thomas's book used the parameter A to describe about the gain. And V over here is voltage, means that voltage gain. So in order to calculate the gain is actually output over input. Okay, output over input. So that means if it is a voltage gain, we are analyzing the V out over V in. Okay, and gain is a parameter without a unit. Okay, because it is a ratio of output over input, so there's no unit. Okay, so what we want to analyze is actually about amplifier. Okay, so before that, if you see, if you read other literature books, okay, other literature books use the term as G. Okay, it use the terms of gain as G for gain in other literature books. But for Wayne Tomasi, he used A for gain. Okay, so it doesn't matter whether A or G. So we understand that it is a gain. And for your information, the ratio of output over input should be bigger than 1. If the value is more than 1, that means it is referred as gain or increment. Okay, so in this subject, we would like to analyze the gain of amplifier. Okay, so amplifier, the symbol is a triangle like this. Okay, we have the input signal and also the output signal. So the gain A is equal to V out over V in. Okay. So this is for the single amplifier. And if we have many amplifier, okay, amplifier 1, amplifier 2, amplifier 3, okay, how can we calculate the gain? Okay, so you see that the gain is given here. A1, the gain for amplifier 1 is equal to 5. The gain of amplifier 2 is equal to 3. And the gain of amplifier 3 equal to 4. Okay, so how can we uh, determine the gain? First of all, you can determine A1. Okay, A1 is actually equal to 5 millivolt divide with 1 millivolt. Okay, so that's why you get 5. A2 is actually equal to 15 millivolt divide with 5 millivolt. So you get 3. And A3, you get 60 millivolt divide with 15 millivolt. So you get 4. Okay. And another thing is that you can also determine the value of V out is equal to ni. So ada bacaan doa. So I think we can take a break for a few minutes. So in FKE, so normally every morning we have a morning dua recitation. Okay. So we have a silence for a while. اللهم إنا خلق العظيم إنك السميع العليم إنك غفور رحيم إنك رب العرش العظيم إنك بر الجواد الكريم اللهم يا كريم يا رحيم يا Allah, bahawa sesungguhnya kami memohon kepada-Mu untuk mendapatkan seluruh kebaikan di sepanjang hari. Dari awal pembukaannya dengan petunjuk hidayat, kami mohon berlindung kepada-Mu dari sebarang kejahatan yang terdapat pada hari ini, pada hari sebelumnya, dan pada hari selepasnya. Ya Allah, baik pulihkanlah pegangan agama kami, kerana agamalah yang menjadi kuasa pengawal segala urusan hidup kami. Perbaikanlah segala urusan takbir persoalan keduniaan kami, kerana di dalamnya kami menjalani kehidupan kami. Perbaikanlah takbir urusan akhirat kami, kerana di sanalah destinasi tempat kami kembali. Jadikanlah penerusan kehidupan ini peluang penambahan segala kebaikan kami dan kematian kami nanti bagai detik ketika mendapatkan ketenangan dan kerehatan. Ya Allah, Ya Rahman, Ya Rahim, Ya Allah, jadikanlah perkhidmatan dan pekerjaan kami termasuk dalam budaya kerja cemerlang, bekerja, masuliah dan itqan sebagai amalan soleh yang mendapat keberkatan dan keredaan. Ya Allah, jauhkanlah kami daripada sebarang perbuatan menyeleweng, sama ada menyelewengkan masa, material dan tenaga. Sebaliknya, jadikanlah kami sebagai orang-orang yang memberi tumpuan kerja dan tugas yang dipertanggungjawabkan kepada kami. Kerana sesungguhnya kami amat takut kepada peringatan balasan nanti terhadap orang-orang yang mengabaikan tanggungjawab. Rabbana alaika tawakkalna wa ilaika anabna wa ilaika al-masir. Rabbana atina fid dunya hasanah wa qina adzabannar. Sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa sallam. Walhamdulillahi rabbil alamin. Okay, that one is dua recitation. Uh, Normally, it will be read in the morning, 8:30 in the morning every day. So all the FKE staff, we take a turn to read the dua, okay, and then after the dua, normally we read a portion of the hadith, okay. So uh, and then I continue again. So as we know that A is a gain is a V out over V in. And for this equation, we can determine the V out. Okay, the output is actually equal to A multiplied, okay, A multiplied with V in. Okay, so we can get the V in. So if you see from uh, these three amplifiers, so the three amplifier systems, this is what we call as the cascaded, okay, cascaded amplifiers. Okay, cascaded means we arrange the amplifiers in a serial combinations, in a serial connections. Okay, so this is cascaded amplifier. So the terms that we use is cascaded amplifiers. And for your syllabus, we will ask you about cascaded amplifiers up to 3 amplifiers. Okay, so that means you don't need to know until 4, 5, 6, or more than three. 3 amplifiers would be enough for this subject. Okay, and if you see from here, we can determine the total gain. If we have a cascaded system, the total gain AT, okay, A total or total gain is equal to A1 multiplied with A2 multiplied with A3. Okay, so 5 times 3 times 4, so we get 60. Okay, total gain would be 60. And if I want to find the V out, okay, V out is actually equal to A total times the V in. Okay, so that means this is 60 times 1 milli. Okay, so that's why we get 60 millivolt, okay, at the output. Uh, so this is a cascaded system. And another thing is that we can also find a power gain, AP. So please correct your lecture notes. P is supposed to be subscript alphabet. So that means you should write like this, A and small p. Okay. So this is actually P out, okay, and divide with P in, okay. So the out and in should be subscript, okay. Uh, so we're gonna see. Normally, we would like to ask you about power gain. Normally, okay, but you can also see about the voltage gain. Okay, sometimes we ask about the voltage gain, but normally we will ask you the question about power gain. Okay, so let's do the example. Class, can I get your response? Are you still there? Masih ada di
Yes.
sana?
Yes, Ate.
Okay. If you don't understand, please ask question. As I said that you can interrupt me anytime. So let's go to the example. The first example. Uh, can you listen to the broadcast voice? Boleh dengar ke suara tu?
Boleh tapi tak dengar sangat.
Okay. Ah. So this is about hadith. So let's wait for a while. وما أوله يا رسول الله ولا علمنا رأي Bapak Sayyidina Umar bin Sayyidina Abdullah bin Umar berkata, saya telah mendengar Rasulullah Shallallahu Alaihi Wasallam bersabda, masa saya sedang tidur pada suatu ketika, yakni dalam keadaan saya telah diberikan semangkuk susu. Saya telah minum susu itu begitu banyak sehingga saya terasa kekenyangan keluar dari buku saya. Kemudian saya telah berikan lebihan susu itu kepada teman. Kalau para sahabat radhiyallahu anhu bertanya, wahai Rasulullah, apakah takbir mimpi itu? Baginda sallallahu alaihi wasallam bersabda, ilmu. Jadi Sayyidina Umar radhiyallahu anhu akan mendapat bahagian yang banyak daripada ilmu Nabi sallallahu alaihi wasallam. Hadis daripada Assalamualaikum warahmatullahi wabarakatuh. Okay, so that one is a hadith, a reading about one hadith. So the speaker is in my room, in all rooms inside the QA building. So okay, so I cannot silent the voice because it is centralized actually for broadcasting within the building. Okay, so I continue again with the first example about gain. So the gain, what is the gain of an amplifier that produces output 750 millivolt for 13 microvolt of input? Okay, so you are given V out, okay, 750 milli, and V in, okay, as 30 micro. So A, okay, A is equal to V out divide with V in. Okay, so 750 millivolt divide with 30 microvolt. So you will get how much? So please open your calculator. Okay, I hope that you can practice using your calculator. So I get this 25,000. Am I correct? Do you get the same answer? Do you get the same answer or not?
Yes.
Okay,
Yes.
easy, right? So this is straightforward. And the next example, the power output of an amplifier is 6 watt. So you are given P out, okay, the output. And the power gain is given as 80. Okay, so A is given as 80. So what is the input power? So P in, we don't know how much is the P in. Okay, so you see that A is equal to P out divide with P in. Okay, and therefore P in, okay, P in is equal to P out divide with A. Okay, so therefore this is 6 divide with 80. Okay, so we get the value of 6 divide 80, so you get 0 0.0075. Okay, 0.075 watt. Yeah, so I rewrite again. So this is 0.075 watt. Or you can say that this is 75 milliwatt. You get the same answer?
Yes.
Okay. And then what? The next example 3. So class, if you have question, you can ask question. Otherwise, I will move to the next example. So example 3, we have a 3 cascaded amplifier. So The amplifier have gains of 5, 2, and 17. So class, if you get this kind of questions, I would like to recommend you to draw, okay, so that you can easily get the idea, okay. So because this kind of question only give you sentences and values, so you cannot picturize these questions in your mind. Okay, so what I would like to suggest to student, normally I always say that even though during the previous semesters, when you get these kind of questions without any picture, without any table, so it is better for you to draw. Okay, so I will draw three cascaded amplifier one, okay, and then amplifier two, and then amplifier three. Okay, so each of the amplifier, it has a gain A1 equal to 5, okay? A2 equal to 2, and A3 equal to 17, okay? So the input power is given as 40 milliwatt. So that means I have P input equal to 40 milliwatt, okay? And the question would be how much would be the P out? How much? Okay. So in order to find this, allow me to calculate above here. So let's calculate over here. Okay. So therefore, the A total, first of all, we can find the A total. A total is equal to A1 multiplied with A2 multiplied with A3. Okay. So here you get a 5 times 2 times 17. Okay, so you get this one 170. Okay, and then the P out. Okay, so we know that A is equal to P out divided with P in. Okay, so we can calculate the P out equal to A. So this is A times P in. Okay, and the A here would be the A total. Okay, you can calculate here the A total. So that means this is 170 multiplied with 40, 40 milliwatt. Okay, so how much this is? So 170 times 40 milli. So you're gonna get 6.8 watt. Okay, do you get the same answer or different answer? Any respond?
Same, Doctor.
Okay, same answer. Okay, if there's no question, then we can move to the next slide. And class, for your information, sometimes I wrongly calculate the answer. Sometimes. So that's why you have to double check my answer with your answer. If you get different values, okay, if I write wrong values for the parameter, you have to inform me, okay? Sometimes I wrongly calculate the answer, sometimes, okay? And you have to double check my answer as well. Okay, next. The next topic would be attenuations. Attenuation, in Malay, we call it as perlemahan signal. Okay, means that the amplitude or the power of the signal will reduce when the signal is transmitted from one point to another point. Okay, mainly due to the distance or maybe due to the collisions with obstacles like building, trees, objects, and etc. Okay, so attenuations in Wayne Tomasi, he also used a parameter. So don't be confused. Gain and attenuation both use the symbol of A. Okay, so it is also calculated as output versus input. Okay, output V out divide with V in. And how do we differentiate between gain and attenuation? What's the difference? The difference, you would see that the value of attenuation will always less than 1. Okay, if you see the value of A less than 1, that means it is attenuation. If you see the value of A more than 1, that means it is gain. Okay, and similar for cascaded attenuation. Okay, if we have cascaded systems, we can calculate the attenuation by multiplying all the attenuations factor, A1 times A2 times A3 and so on. Okay, similar with the gain. Okay, so how to describe the attenuations? If you see the picture on the right, okay, we can see the attenuation parameter, the attenuation factor, by using the example of voltage divider. Okay, so for example, we have a voltage divider over here that consists of two resistance connect to the V in. So V in connect to the R1, okay, R1 and R2. And between the R1 and R2, we tap using a wire here and connected to the ground. Okay, okay. So this is V out. Okay, so the V out over here is measured as R2 divide with the total resistance multiplied with the input. Okay, so the output is actually a portion of the total voltage. Okay, is also is actually a portion of the V in. Okay, because we are tapping on the R2, so that means R2 over R1 plus R2 multiplied with the V in, so that we can get the V out. And if you see from here, V out would be less than V in, because we are measure the output from the R2. Okay, so the parameter R2 over R1 plus R2 is actually the attenuation. Okay, the attenuation of V in. Okay, the attenuation of V in. So if you see, if I draw a picture like this, so we have input system. Okay, we have the input and then we have the output. So this is a system. This is a system. So we have V in over here and we have V out over here. For attenuation, okay, for attenuation, V out will less than V in. Okay, so that's why we get attenuation. Okay, so for this case, the ratio of R2 over R1 plus R2 is actually the attenuation factor. Okay, the attenuation factor. So R2 divide with R1 plus R2. So 100 divide with 100 plus 200. So 100 divide with 300. So we get 0.33. Okay, so that means the output is only 33% from the input. Okay, so if you want to find the output, okay, if you put over here 0.33 of the V in would be the output in this example. Okay, and we can try to calculate the cascaded. For example, we have the cascaded attenuations, okay, cascaded network to calculate the attenuations. So let me divide the slide into two parts. The picture below is a different thing. Okay, let's see the above picture. So if you see the above picture, we have three loss stage. Okay, three loss system. loss stage, loss circuit, loss component. Okay, so whenever you see the loss, that means each system will produce attenuation. Okay, that means each system consists of A1, A2, and A3. And if you see from here, A1 is 0.2, A2 0.9, A3 is 0.06. Okay, and you see that the value is less than 1. Okay, the value is less than 1. That means this is confirmed. This is a attenuation. So each system produce attenuation. Okay, and I can predict from here that the V out would be less than the V in. Okay, the V out is less than the V in because all the A parameter is less than 1. Okay, so how can I calculate the V out? So first I have to find the total attenuation. So A total would be equal to A1 multiplied with A2, okay, multiplied with A3. So I get 0.2 multiplied 0.9 multiplied with 0.06. So I get 0.0108. Okay. Then I can calculate the V out. V out is equal to A total multiplied with the input voltage. Okay, that means 0.0108 multiplied with 3 volt. Okay, so if you use your calculator, 0.0108 times 3, you're gonna get 0.0324 or 32.4 millivolt. Okay, so this is straightforward. Okay, and the next part, if you see about offset, attenuation, if you see the picture below, so it is said over here, the attenuation can be offset by introducing gain. What does it mean by offset? Okay, offset means that we want to make the value of A to become 1. Okay, if we make the value equal to 1, that means we can offset the attenuation. We can also offset the gain. Okay, so in this example, if we want to offset the attenuation, we have to introduce additional gain. Okay, so if you see from the above picture, if you see the above picture, A total is less than 1. Okay, if I want to offset the A total, I have to introduce another gain in the system so that the A total would become 1. Okay, so the meaning of offset, we want to make it A equal to 1. So what happened if A equal to 1? That means, okay, that means V in would be equal to V out. Okay, if V in is equal to V out, that means we have offset the attenuation, or we can also offset the gain. So in this slide, if you see that this is based on the previous example of the voltage divider. Okay, so for example, here we have a voltage divider. So this is similar with the previous one, similar with this one. So if you see here at this point, we can measure the output. For example, this is point X, for example. So at point X, we can measure the attenuations. Okay, at point X, if we measure using a voltmeter, we connect to R2 and to the ground. So we can measure the V out. We can measure the attenuations is equal to 250 divide with 250 plus 750 ohm. And then if we multiply it with V in, we can get the value of X. Okay, the value of X in terms of volt. Okay, but from the value of X would be less than V in. Okay, the value of X would be less than V in because we have the attenuation factor. Okay, this is the attenuation factor. So how can I make the V in equal to V out? Okay, how can I make the V in equal to V out? I have to introduce another gain. Okay, but before that, if you see from here, okay, the attenuations, okay, the attenuation A1 is equal to 250 divided with the total resistance. So 250 divided with 1000, so we can get 0.25. Okay, so this is the first A, okay, the first attenuation. And how can I offset A to become 1? How to do that? In order to offset, that means we have to introduce additional gain. You see that we introduce an amplifier after the point X. Okay, at point X, we introduce additional amplifier. But how much would be the gain? Okay, how much would be the gain? Okay, so we want to introduce additional gain. We call it as A2. But how much should we introduce the gain? Okay, so now remember that V1, sorry, so we need to introduce another gain so that we can achieve A1 multiplied with A2 equal to 1. Okay, so initially I have the attenuation 0.25. I don't know how much I would introduce A2, and I should achieve 1 to offset the attenuation. Therefore, A2 is equal to 1 divided with 0.25. So this is equal to 4. Okay, equal to 4. So that means I need to introduce additional gain equal to 4 so that the output would be equal to input. Okay, so if I introduce A2 equal to 4, that means the output is equal to input. Okay, this means that I already offset the input. Okay, I already offset the input by introducing additional gain. Okay, so this also frequently asked in the test question. Okay, where we give a cascaded system, and we ask the student how to offset the attenuations. How much would be the additional gain that we should introduce into the system so that we can get the output equal to the input. Okay, so this is the offset process. Next, if you see from this example, okay, we have loss stage. The first one, loss stage, and then we have gain. Okay, and then we have another loss stage, and then we have another gain. Okay, so you see that class, since the gain and also the attenuation use the same parameter A. Okay, we are using A, right? So A can be gain, A can also be attenuation. So we can mix up both of it. Okay, we can mix up the gain and the attenuation, okay, in a network of systems. Okay, so if you see from here, we have the input 15, we have the input 1.5 volt, and this loss stage has a attenuation 0.1. How do I know attenuation? Because the value is less than 1. So this is attenuation. So if you see 1.5, if you multiply with, you see that so V out 1 is equal to A1 multiplied with V in. Okay, so if you multiply 0.1 You multiply it with 1.5, you will get 0.15. Okay, similar like the others. Okay, so the next part is the amplifier produce gain A2. A2 equal to 10. And if I multiply A2 with 0.15, I get 1.5 volt at the output. Then we have another loss stage. Okay, the value is A3. A3 less than 1, so this is attenuation 0.3. If I multiply A3 with the input of loss stage, I'm gonna get 0.45 volt at the output. Then the last one would be an amplifier which produce additional gain A4. A4 is equal to 15. If you multiply 15 with 0.45, you will get the output 6.75 volt. So this is how we calculate one by one. But we can also calculate straight away, okay, by measuring the total A. Okay, so the A total, okay, if you see A total is equal to A1 multiplied A2 multiplied A3 multiplied with A4. So you see that class, regardless whether this is gain or this is attenuation, we can multiply the values. Okay, so A1 is 0.1 multiplied with A2 equal to 10 multiplied with A3 equal to 0.3 multiplied with A4 equal to 15. So we're gonna get 4.5. Okay, and from here we can measure the output, okay, by doing like this. V out is equal to A total multiplied with V in. Okay, so if you see 4.5 multiplied with 1.5, so you're gonna get this 6.75 volt. Okay, so allow me to correct this. This is volt. Okay. Okay, class. Do you understand this? Boleh
Yes.
faham, eh?
Yes, betul.
Okay. Thank you for the response. So if there's no question, we can move to the next slide. Okay, the next example. So if you see the next example, this is about attenuation and also about offset. Okay, so a voltage divider shown in figure 1.7. Which one is 1.7? 1.7 is like this. Okay, 1.7. Okay, so we can draw the voltage divider that has a value of R1 equal to 10K and R2 equal to 47 kilo ohm. Okay, so if I draw the voltage divider R1 and also R2, and then connected to the ground. Okay, so this is R1 equal to 10 kilo ohm. Okay, and then R2 equal to 47 kilo ohm. Okay, so this is a voltage divider. So voltage divider would be connected this at this point. Okay, so actually we want to measure this. So this is the V out actually. So the V out. So we measure the V out we by tapping at the R2. So the V out would be a fraction of voltage less than the V in. So the V in is over here. Okay. So the attenuation factor for this example is actually equal to A equal to uh, R2 divide with R1 plus R2. Okay, so this is equal to 47 kilo ohm divide with 10 kilo ohm plus, okay, plus 47 kilo. Okay, how much would this one? So 47 divide with 57, so you get 0 0.82, 0 0.825. Okay, 825. Class, can you get the same answer?
Same.
Okay, so this is the attenuation. So we already answered the first question. Okay, and then what? The next question asks you what amplifier gain would you need to introduce to offset the loss for overall gain equal to 1. Okay, means that we need to introduce additional. Okay, we want to introduce additional wait, so previously we use this is V out 1. Okay, and then I introduce additional gain, so this is A2. Okay, so we can measure A1 over here, and A2 is here. How much we don't know. Okay, but what we want to achieve is that A total, so this is V out, the second V out. So A total, since we want to offset, that means A total would be equal to A1 multiplied with A2. Okay, so this is equal to 1. So this is equal to 1. Okay, so therefore, if we measure this, this is 0.825 A2 is equal to 1. So therefore, A2 would be equal to 1 divided with 0.825. So I get 1.212. 212. Okay. So I need to introduce a gain equal to 1.212, so that I can offset the total A parameter. Okay. Do you understand, class? Is it okay?
Yes, sir.
Okay. So let's go to the next example. Example 1.5, an amplifier has a gain of 45,000, which is too much for the amplification. Okay. So with an input voltage of 20 microvolt, what attenuation factor is needed to keep the output voltage from exceeding 100 millivolt? Let A1 amplifier gain 45,000, A2 attenuation factor, AT is total gain. What is this actually? Okay, so you see that the first one we have amplifier. Okay, we have the amplifier. This amplifier, okay, if you see that this is A1, has a gain of 45,000. Okay, and the given input, okay, the input given is V in equal to 20 microvolt. Okay, so the question said that this amplifier has a lot of gain. Okay, so we should reduce the output. And so if we have this gain, this big gain, okay, how much would be the V out? Okay, let's try. Okay, let's try. V out is equal to 45,000 multiplied with uh, 20. Okay, so this is actually, so maybe I can draw like this. So A1 multiplied with V in. Okay, so this is 45,000 multiplied with 20 microvolt. Okay, how much would be this? So if you see 45,000 multiplied with 20 micro, I would get 0.9, 0.9, or you can say that this is actually 900 millivolt. So this is too big. Okay, we want it to be less or equal. We want the V out. Okay, which is too big. This is too big. Okay, so we want the V out. Okay, we want the V out to be less or equal to 100 millivolt. Okay, this is our target. Okay, so in order to do that, we need to introduce additional attenuation. Okay, so if I redraw again, okay, so we have this one. So this is a V in equal to 20 microvolt. I have a amplifier over here, A1 is equal to 45,000. And then I need to introduce two additional attenuation, okay, A2, which I don't know how much should, okay, I don't know how much. And I want to produce an output equal an output. So an output is less or equal than 100 millivolt. Okay. So what we can do is uh, that means first we want to make sure that we know that the V out. So let me calculate. So let me calculate this one. So V out is actually equal to A total multiplied with the V in, right? So how much would be the A total? A total in this case, if I multiply, so A total is equal to A1 multiplied with A2. So what I get is 45,000 A2. Okay, 45,000 A2. And what I can do is that, okay, for the V out, I can take the upper bound values. Okay, because I don't want the output to be more than 100 milli. So I can take the upper bound value 100 millivolt, okay, equal to A total times V in. Okay, so this is 45,000 A2 multiplied with 20 microvolt. Okay, 20 microvolt. And let me draw over here. So if you see from here, class, sorry, battery. Okay, so if you see from here, 45,000 multiplied with 20 micro input, right? So I get 0.9 A2. Okay, so therefore, I can measure the value of A2 is equal to 100 millivolt divide with 0.9. Okay, so 100 milli divide with 0.9. So I will get 0.1111, right? So 0.11111, okay? So 100 milli divide point 0.9, so 0.1111. So class, if you ask me in the exam, how much decimal value should I write? So if you ask me, I would recommend you to write up to 3 or 4 decimal point. Okay, so in this example, let's simplify to 3 decimal point is enough actually. So 0.111. Okay, that means uh, the attenuations that I should introduce should be A2 equal to 0.011. Okay, so this is the maximum A that I should, the maximum attenuation that I should introduce. Okay, so if I want to make it less than 100 millivolt, I should reduce the amount of A2. Okay, so if we put A2 equal to 0.111, that means we will achieve the maximum limit of output voltage. Okay, and if we want to make it less than 100 milli, then we should make the A2 less than 0.111. Okay, so this is the upper bound, the maximum value of attenuation that we should introduce to make the output equal to the maximum 100 millivolt. Okay, so if I want to make it less, that means I have to make the A2 value much smaller than 0.111. Okay, boleh class? Do you understand this?
Yes.
Okay, so let's go to the next topic. Okay, so the next topic is about decibel gain. Okay, decibel gain, or we use the parameter dB. So I believe some of you, or maybe all of you, already know about dB. So dB would be decibel gain. Okay, dB would be the decibel gain. So if we convert the value of A, so A, the A parameter, either this is a gain or attenuation, we can change it into a dB value. Okay, we can change it into a dB value. Previously, we have learned that the parameter of A is a unitless parameter. Okay, because it is a ratio of voltage, it is a ratio of power. So it is a unitless parameter, tanpa unit. Okay, and if we want to convert a parameter without a unit, it would become a decibel. Okay, it will become a decibel. So you're gonna see later what's the good thing about decibel. So decibel, you will see later that if we use decibel, it will be easy for us to do the calculation of certain parameters. Okay, decibel allow us to reduce the number of large values. Decibel also will help us to increase a parameter value that has a very small value. Okay, so we're gonna see later about this. So you see that class, a value in decibel is equal to 10 log uh, 10 log what they call the basic 10, 10 log basic 10 of absolute value. So that means uh, we can write like this, 10 log of A. Okay, 10 log of A, for example. A can be gain, A can be attenuation. Okay, so let's try this. The first example over here. For example, we have A parameter equal to 2. So in decibel, we can change it 10 log of 2. So we can get this 3 dB. Okay, 10 log of 2 equal to 3 dB. So you can try use your calculator. 10 log 2, so you get 3.01. So this is, if you use calculator, you get 3.01. Okay, so in your lecture notes, sometimes the value has been rounded up for easy understanding. Okay, for easy understanding. But in the test or final exam, you have to write up to 3 decimal point. Okay, so you see that the value is 3 dB and this is a positive value. Okay, so you see that if the value is more than 1, you will get a decibel value, a positive decibel value. And another example, if you see A equal to 0.5, okay, in decibel, we can change it as 10 log 0.5. So you will get minus 3 dB, okay, 10 log 0.5. So you get minus 3.01, okay. So this is minus 3 dB. So minus 3 dB, okay, whenever you see minus, that means this is a attenuation or loss, okay. So a value of decibel in negative means that it is a loss or it is a attenuation, okay. And I give you another example. What about if a value, okay, for example, A is equal to 1000. For example, how to convert this one? So if I want to convert this into decibel, that means 10 log 1000. How much? I get this as 30. Am I correct? 10 log 1000. So 30. 30, 30 of what? 30 of dB. Uh, okay. So you see that one of the good thing about decibel, it will reduce large number 1000 to become only 30. Okay, so if we play around with a small value, so easy for us to do the calculation. Okay, uh, decibel power. uh, Decibel power. So before we go to the decibel power, okay, so this decibel, okay, before I forgot, so you see that class, um, we can find the value in decibel for a parameter without a unit. Okay, parameter without a unit is, you see that what's the difference? Okay, so I have a value of 100, for example, a unitless value, and I can also have 100 watt. So both of these is different. Okay, it's not similar. Okay, I can change this into a dB. Okay, but if I want to change this into decibel, it would become a decibel power. That means this is a dBW, which we're going to see later in the next slide. Okay, the next slide is conversion of power into decibel. Okay, so we can change power value. Okay, we can change a power value into a decibel power value. Okay, so we have a decibel over here. You see that this is a dBW, dB watt. We have dBm, dB milliwatt. We have dB micro, dB microwatt. Okay, so what's the difference? So let's try to see the difference. So there are a few examples over here. There are a few examples. So uh, you see that I would like to go to the last example first. The last example first. So we have here 1000 milliwatt. We want to convert it into decibel. Okay, so 1000 milliwatt is actually equal to 1 watt. Okay, and we want to convert it into dB watt. So therefore, we can calculate 10 log of power, okay, 1 watt, divide with reference value 1 watt. Okay, and we get 0 dBW. Uh, okay, I can give you another example. If I have 10 watt, for example, okay, I can change it into 10 log of 10 watt, okay, divide with 1 watt of reference. Okay, why 1 watt? Because I want to convert it into dBW. Okay, so 10 log of 10, how much? Okay, so this is 1 dBW, right? Sorry, not 1 dBW. Okay, so 10 log 10, so we get 10 dBW. Okay, another example. Okay, class, if you cannot get what I write over here, please ask question. Okay, okay, let's go to the next example so that easy for you to understand. So now we want to convert into dBm, dB micro. Okay, so we have 1000 milliwatt. Okay, and we want to convert it into dB milli. Okay, dB milliwatt. So therefore 10 log 1000 milliwatt of power that we want to convert, and we divide into we divide with 1 watt. So this is actually the reference value. Remember, when we want to convert into dB milli, the denominator should be in term of milliwatt. If I want to convert into dB micro, okay, so if I want to convert into a dB micro, so that means 10 log of power divide with 1 micro. So I will get a value in term of dB micro. Okay, if I want to convert into milli, that means 10 log of power divide with denominator of 1 milli, sorry, 1 milli, 10 power of minus 3, I will get a value in terms of dB milli. Okay, so in this case, if I go back to the second example, okay, so 10 log 1000 milliwatt divide with reference 1 milli, so I get 30 dBm. Okay, and if I want to convert the next example, the next example, if I want to convert 1 milliwatt into dBm, okay, so therefore 10 log of power 1 milli divide with reference 1 milli. Okay, so 10 log of 1, so I get 0, but the value is dBm. Okay, so class, if you already get used to this, okay, if you already get used to this kind of calculation, so you can just calculate directly. So dBW to dBm, okay, you just need to plus with another 30. Okay, from dBW to dBm, you will need to plus with 30. Okay, uh, so if you want to convert into dB micro, for example, you need to convert into a dB micro. Okay, so you need to plus another 30. Okay, so in this case, I can change this into a dB micro, so it will become 60 dB micro. Uh, if you want to try, you can try it. 1000 milliwatt divide with 1 micro, so you get 60 dB micro. Okay. So next, let's try this example. Okay, so This example, you might need to do as your homework, to practice the power, the dB calculations. So I will give you a few examples over here. Okay, I will give you a few examples. So you see that this table consists of power in milliwatt. Okay, you are given the value in terms of dBm, and you need to find how much would be the dBW. Okay, so let me give you the first example, 0.01. Okay, so if you see from here, 10 log of power 0.01 divide with 1 milli. Okay, 1 milli, I get the value equal to how much? So so this is actually milli. So eh, this is actually milliwatt, divide with 1 milli. So it's gonna be 10 log 0.01. So I get minus 20. I get minus 20. So maybe I can make it like this for you to easy for you to understand. So this is actually 10 power of minus 3. Okay. So you're gonna get the value equal to minus 20 dBm. Okay, so this is dBm. Okay, if I want to convert it into dBW, so that means this is 10 log of power 0.01 times 10 power of minus 3 divide with 1 reference value. How much would be? So you see that 10 log 0.01 milli, I will get the value equal to minus, so this is minus 50 dBW. Okay, minus 50 dBW. Let's try another example. This one, 0.1. Okay, so 10 log 0.1 milli divide with reference 1 milli. Okay, so therefore 10 log 0.1. Okay, milli and milli you can cancel. 10 log 0.1, you will get minus 10. Okay, so you get the value minus 10. And if I want to change to dBW, that means 10 log of power 0.1 times 10 power of minus 3 divide with 1 reference value. I want to convert it into dBW. So therefore, I will get the value equal to, so 10 log 0.1 milli. So I get this one equal to minus 40 dBW. So this is actually minus 40 dBW. Okay, class, can you get the answer? Can you get the same answer?
Yes.
Okay, let me try the last one for you. 1000 milliwatt. Okay, so we can try use this one. So I will make a line over here. So this one. So 10 log 1000 milliwatt. Okay, so 1000 milli minus 3 divide with 1 milli reference. Okay, so this is 30 dBm. Okay, similar with this one. Okay, and if I want to convert it into dBW, that means this is 10 log 1000 milli divide with reference 1. Okay, so I get this. So this is 10 log 1 actually, 10 log 1. So I get 0 dBW. So this is supposed to be 0 dBW. Okay, and I think the rest you can answer by yourself. You can answer by yourself. Uh, okay. So the next you can do homework, you can practice at home. And if you ask me, of course, this kind of question will come out in the test. Okay, so you have to practice by yourself. Okay, please practice by yourself so that you can answer uh, the test question later. Okay. Okay, so let's go to the next example. So decibel is also used to measure the ratios, gain, attenuation, SNR. So the power ratio in communication is usually expressed in dB, 10 log 10, okay? 10 log, so please correct your notes. This 10 should be subscript. This is supposed to be subscript. Okay, so it's actually like this. 10 log of 10 uh, P1 power 1 divide with power 2. Okay. Uh, so you see that this is how we measure this is in decibel. So we are not getting dBW, dBm anymore because this is ratio. Okay. When we divide power, watt and watt, we will get a value without a unit. Okay. So you see that class, this is a unit, this is a value without a unit. Okay. If you divide P1 and P2, you will get a value without a unit. Okay. So therefore, we're going to get the answer in dB. As I said previously, a value without a unit, if we change into decibel, we're going to get the unit going to be decibel, dB. Okay. Uh, it different from the previous one. This is we convert power. If we convert the power into decibel, so it becomes dBW, dBm, or dB micro. But if it is a unitless parameter, for example, like this, a ratio of power would become a unitless parameter. So if you change a unitless parameter, it will become dB. Okay. So if you go from here, okay, so this is 10 log of P out over P in. Okay. And then if you see voltage and current, why suddenly 20? And this is 10. What happened? Okay, what happened? So this is not a magic number. Okay, so it comes from the Ohm's law, V equal to IR, right? So power can be equal to V square over R, right? So power can also becomes I square R. So this is the same thing that we have calculated previously, since long time ago, now and forever. So the power calculation is still the same. Okay, nothing changed actually. So when you want to um, find a power ratio in terms of voltage, so you see that P1 over P2, for example, so this is V square, V1 square over R. You divide with V2 square over R. Assuming that the R is the same, you can cancel out. Okay, so that's why you get V1 over V2. So that means this is V1 square divided with V2 square. Okay. So therefore you see that if I convert this, so I can make it if I convert this into decibel, that means 10 log in bracket V1 over V2 square. Okay. So this square can be put in front actually. So that's why it becomes 20 log of V1 over V2. Okay. So 20 is not a magic number, guys. Okay. So 20 log V out over V in. So we get the voltage ratio. Okay. And for the current, okay, for the current, so you see that current is okay. So this is actually, if you see from here, this is 10 log of current. Okay, so I can say that I out square R divide with I in square R. Okay, so R can be cancelled out. Okay, so that's why it becomes 10 log I out over I in square. Okay, and therefore you can get this 20 log. Okay, you can put the square in front, so it becomes 20. Okay. Okay, so let's do this example. Okay, let's example 1.6. Okay, example 1.6. A microphone has an output value of minus 50 dBm. Calculate the actual output power. Okay, so a microphone has a value of P out equal to minus 50 dBm. Okay, so the question asks you about how much power, how much will be the output power in terms of uh, we can measure the P out in terms of, for example, milliwatt. Okay, how much will be? Uh, okay, so let's do this. Okay, uh, 10 log. Okay, so this is, I can say that X is equal to minus 50 dBm. Okay, so if I do like this, okay, the value of X that I will get later would be in terms of milliwatt. Okay, the value of X would be in milliwatt. Okay, I will show you later. Okay, so therefore log of X is equal to minus 5. Okay, so X would be antilog of minus 5. How to use antilog? Okay, if you use my calculator Casio FX570MS. Okay, so antilog is actually shift log. Okay, shift log minus 5. So I get 10 power of minus 5. Okay, so this is 10 power of minus 5. What's the unit? The unit would be milliwatt.
Sir,
Uh,
sir,
yeah,
anti-lock tadi macam mana?
anti-log. Okay, anti-log, what you can do is shift log and then you can write minus 5. Okay, shift log minus 5. So you're gonna get 1 power of minus 5. So this is actually like this. So this is actually 1 times 10 power of minus 5 milliwatt. Okay, boleh dapat tak?
Boleh, boleh.
Okay. In your calculator, you will see the symbol like this. In your calculator, you will see the symbol like this. This is in the calculator. So if you want to convert, if you see from here, if I convert this, the whole thing in the bracket, if you see, class, the whole thing in the bracket is actually in milliwatt. How do I know that? Because this is in dBm. Okay. I give you another example. Okay. If 10 log x, for example, if this is equal to 50 dBW, for example, okay, so everything inside the bracket, okay, everything inside the bracket would be in terms of watt, okay. So this is x would be equal, log x is equal to minus 5. So this is, I can say that this is dBW. Sorry, this one is minus, this is dBm. Okay. So x would become anti-log of 5. Okay. Anti-log of minus 5, I get 1 times 10 power of minus 5, but the unit would be dBW. This is another example. Okay. Similar if this is a micro. Okay. Okay, class, I give you another example. Okay, so that you can get more, you can have more understanding. Okay, so 10 log, I give you another example, x. I don't know how much is x. Okay, and this is minus 50 dB micro, for example. Example. So x is equal to minus 5. Sorry, log x. Log of x is equal to minus 5 dB micro. Okay, x is equal to anti-log of minus 5, so I get 1 multiplied with 10 power of minus 5 micro watt. Okay, so this is another example. So the answer for this example, okay, the answer for this question, example 1.6, is 1.1 times 10 power of minus 5 milliwatt. Okay. Class, do you have question about this?
No.
No question. Okay. So, wait, can submit. So before we move to the last example, before we move to the last example, let us try to study the next notes, the next lecture notes. Before I go to the last example, I want to show you about this. So this you can get from the author platform. I already gave you in the author, and I also gave you in the WhatsApp group. If you see from the WhatsApp group, I gave this lecture notes previously about the dBm. Okay, So let's try to learn about this first, then we can learn about the last example. Okay. So the next lecture notes was written by Dr. Hairun Nizam. So Dr. Hairun is also a lecturer in FKEE, so he wrote these lecture notes previously. Okay. So conversion of dB, dBm, dBw. Okay, so we're gonna see a few different things, a few different parameters: absolute ratio, decibel, dBm, and also dBw. Okay, so for conversion, convert the following power gain values to absolute ratio. So you are given 10 dB, 0 dB, and minus 10 dB. Okay, so if you want to convert this, okay, so you see that 10 log of a, so you see that here 10 log of a is given as 10 dB from the question. The question wants you to find how much would be the value of a. Okay, so you can go one by one. Log of a is equal to 1. Okay, so 10 divided with 10, so it is a 1. So A would be equal to anti-log of 1, so you get 10. Okay. And another example would be 0 dB. How much would be the value of A? So 10 log of A would be equal to 0 dB. So log A equal to 0. A equal to 10 power of 0, so you get 1. Okay. So you can try use your calculator. 10 power of 0 become 1. Okay, power of 0 will always give you equal to 1. Okay, so this is 1. Okay, and then 10 log of a, this is minus 10 dB, so log a equal to minus 1. So a is equal to 10 power of minus 1, so you get 0.1. So this is attenuations. Okay, so power of 0.1, so you will get attenuation. Okay, next, convert the following in values into dBm. Okay, so remember, when we want to convert power into dBm, that means this is 10 log of power divide with 1 milli of reference. Okay, so we have one micro, 1 milli, and 1 watt. So we can convert it like this. Okay, the first example we have 1 micro, right? So the first one is 1 micro. So this is the power. Divide with reference 1 milli. So 10 log of 10 power of minus 3. Okay, so we get minus 30 dBm. So you can try use your calculator, class. 10 log 10 power of minus 3. 10 power of, so this is actually 10 log 1 times 10 power of minus 3. Okay, 10 log 1. Okay, so you get minus 30, but the unit is dBm. Okay, why dBm? Because we divide with 1 milli reference value. Okay, another example, 10 log of 1 milli. So this is the power now given is 1 milli. Divide with, so you divide with 1 milli reference. Okay, so 1 milli divide with 1 milli, so it becomes 1. So 10 log 1 becomes 0, but the unit would be dBm because our reference is 1 milli. Okay, another example, 1 watt of power. Okay, 1 watt of power convert into dBm. So 10 log 1 watt of power divide with the reference 1 milli. So 10 log of 1000. So this is 10 log of 1 times 10 power of 3, 1000. Okay, so becomes 30. 10 log 1000, you get 30, but the unit is dBm because the reference would be 1 milli. Okay. If you have question, please ask question. Okay, please ask. I will try to explain more. Okay. If you keep quiet, that means I assume that you can follow my explanation and you can understand. Okay. Let's try the next part. Okay. Convert the following dBm into microwatt. So this is like the previous example that we have done. Okay. So convert this into a milliwatt value. Okay. Similar like this. Convert into a value in milliwatt. This one also in milliwatt. Okay. So what what you see from here. Okay. Uh, so 10 log. Okay, the first example is 30 dBm. So you want to convert this into milliwatt. So therefore, 10 log of power in bracket. So this in bracket, everything inside here would be in terms of milliwatt. How do I know that? Because the answer here is dBm. So if the final value is dBm, that means everything inside the bracket would be in milli. If if the output here is micro, that means everything in the bracket will be in micro. If the output here is in dBW, that means in bracket will be in watt. Okay. So therefore, we can divide with 10. 30 divide with 10, so we get log 10 of power in bracket. Okay, you get minus 3. So therefore, power in the bracket, power in milliwatt would be 1 times 10 power of minus 3 milliwatt. Okay, so this is actually 1 times 10 power of minus 3 milliwatt. Okay, or you can say that 1 microwatt actually, because milli and milli, so you get 1 times 10 power of minus 6. Okay, because this is minus 3, another minus 3, so it's actually 1 microwatt actually, if you play around with the watt. So finish the first example. Another example is 0 dBm. How much would be the power? Okay, so 10 log of power in the bracket, which is in milliwatt. Okay, so divide with 10, 0 divide with 10, you get 0. Okay, so log of power in the bracket, you get 0. So power in the bracket is equal to 10 power of 0 or anti-log 0. Anti-log of 0, you get 1. And the unit is milliwatt. Okay, easy, right? So finish example 2. We can go to the next example. Okay, so 30 dBm convert into power. Okay, so 10 log of power in bracket. The power in bracket is in milliwatt. Okay, 30 divide with 10, so you get 3. So log of power in the bracket equal to 3. So power in the bracket, which is equal to milliwatt, is equal to anti-log of 3. Anti-log of 3, you're going to get 1000. So this is actually 1 times 10 power of 3 milliwatt. Okay, so 1001. So you can try anti-log shift log 3. So you get 1000. 1000 milliwatt. Okay, can you follow? Can I get your response? You can follow my explanation.
Yes. Yes, sir.
Okay, so let's go to the next example. Convert the following to dBW. Okay, so you want to change all of this into dBW. Okay, we want to change all of this in dBW. Okay, so the first example, 10 log uh, this is okay. So 10 log of power. So how do we convert? So we convert like this, 10 log of power, we divide with the reference value of 1. Okay, so we get the value in terms of dBW. The first question is 10 watt. Okay, 10 watt. 10 watt divide with reference 1. So 10 log 10, you get 10 dBW. Okay, 10 log 10, you get 10. And then you are given 1 watt. Okay, the next question is 1 watt. So 10 log 1, okay, 10 log 1, you get 0. And the unit dBW. Okay, the last question is 10 log 1000 watt. Okay, given 1 kilowatt. So 10 log 1000, you get 30. And the unit is dBW. Remember, every value in the bracket is divided with reference 1. Okay, reference 1 watt. Okay, so this is straightforward. Then the next example, convert the following dBW into watt. Uh, so you are given 10 watt, uh, 10 watt, 0 dB, sorry, 10 dBW, 0 dBW, 30 dBW. So you want to convert this into a value in terms of watt. Okay, convert into a value in terms of watt. Okay, so the first one, 10 log 10, sorry, 10 log of power in the bracket equal to 10 dBW. Okay, so everything inside the bracket would be in terms of watt because this is dBW. Okay, so 10 divide with 10, so we get 1. So log of power in the bracket is equal to 1. So power in the bracket in terms of watt is equal to anti-log of 1. Okay, shift log 1, you get 10. Okay, and the unit is W. Okay, so you see that this is W. The next example, 10 log of power in the bracket is equal to 0 dBW. Okay, so 0 divide with 10, so 0. Okay, so therefore power in the bracket in terms of watt is equal to anti-log of 0. Anti-log of 0 is equal to 1. Okay, shift log 0, you get 1. And the unit is watt. Okay, so you see that watt and watt. The third example, 10 log of power in the bracket equal to 30 dBW. Convert into watt. Okay, so 30 divide with 10. Okay, 30 divide with 10, you get 3. Okay, so log power in the bracket log power in the bracket is equal to 3. So therefore power in the bracket is equal to anti-log of 3. Okay, shift log 3, you get 1000, but the unit is watt. Okay, so same watt and watt. Okay. Next, combine power in log scale. Uh, from here you get new knowledge. If you see from here, uh, determine 1 milliwatt plus 1 milliwatt. So this is straightforward. I believe you know this. So 1 milli plus 1 milli, so you get 2 milliwatt. Straightforward. Okay. Another example, 0 dBm plus 0 dBm. So the answer is not 0. Okay, the answer is not 0. So if you see there's a power unit, this is a power unit, dB milliwatt, dB milliwatt. You cannot directly add, you cannot directly add both of the value. You have to convert into power, then you do the addition process, then you convert back into dBm. Okay. So 0 dBm plus 0 dBm is not allowed. But what you can do, you should convert into power first. Then you do the process addition. Then you convert back the answer in terms of dBm. So how to do this? You see that first we have to convert 0 dBm. Okay, we have to convert 0 dBm into power. Okay, so 10 log of power that we want to find, so the power here is in terms of milliwatt. Okay, so 0 divide with 10, so I get 0. So the power in the bracket in milliwatt is anti-log of 0. Anti-log of 0 is equal to 1. And the unit is milliwatt. So therefore, 0 dBm plus 0 dBm is actually equal to 1 milli plus 1 milliwatt. So you get 2 milliwatt. Okay. From here, you can convert into dBm. Okay. So therefore, 10 log 2 milliwatt. Okay. 2 times 10 power of minus 3. Okay. This is what? Milliwatt divide with 1 times 10 power of minus 3. Okay. 1 milli reference. Okay. So 10 log 2. So therefore, we get 10 log 2. So the answer is 3.01 and the unit is dBm. Okay. Can you follow this explanation? Boleh faham ya?
Boleh.
Boleh je.
Okay. Another example. Okay. Another example. 0 dBm plus 3 dB is equal to 3 dBm. This is allowed. So 0 dBm is actually a unit of power actually. 0 dBm is a power. While 3 dB is a unitless parameter. Okay, so this is a unitless parameter. So you get 3 dBm. Okay, if I do another thing, 0 dBW plus 3 dB. So this one will be, it will follow this one. It will follow the unit of dBW. So I will get 3, but the unit is dBW. I give you another example, 0 dB micro plus 3 dB. So this is 3, but the unit is dB micro. So how come it will be like this? Macam mana boleh jadi macam ni? Okay. So I give you a simple analogy, class. I give you a simple analogy. For example, I have 10 watt. Okay. And I want to multiply this with 5. How much is this one? Anybody can give the answer? How much is it? How much is the value? Anybody want to answer this? 10 watt times 5, how much? Hello?
50
50 of what? What's the
watt.
unit? Yes, 50 watt. If I give you another example, 10 milliwatt times 5, the answer would be also 50, but the unit is 50 milliwatt. I give you another example, 10 microwatt times 5. It would be 50, but the unit is microwatt. So what I want to show you here is that a multiplication process, a multiplication process, okay, a multiplication process in a non-decibel parameters, a multiplication process for a non-decibel parameters is equal to the addition process in decibel. Okay, so the addition process, this one, so this plus in decibel is actually multiplication process of a unitless parameter. Okay, so that's why I come up with this analogy, 10 minus 5. Okay, so the multiplication process for a non-decibel parameters is equal to the addition process in decibel. Okay, and you're going to see this more later. Okay, another example, 0 dBm plus 5 dBm. This is not allowed because both dBm and dBm. Okay, so I also want to ask you, what about 0 dB plus 5 dB? So this is allowed. This is 5 dB. dB and dB is allowed. 5 dB. Okay. But dBm, dBm, dBw, dBw, dB micro is not allowed. Okay. If you get dBm, dBm, you have to convert into power first. So 0 dBm, if you convert into power, okay, 10 log of power in bracket equal to 0 dBm. So 0 divided with 10, 0. So power in the bracket is anti-log of 0 equal to 1. And the unit is milliwatt. Another parameter is 5 dBm. Convert into power. So 10 log of power in the bracket equal to 5 dBm. So the power in the bracket in dBm is anti-log, the power in the bracket is 10 log of power in the bracket 0.5, anti-log of 0.5, you get the power in the bracket, which is 3.1632, but the unit must be milliwatt. Try it, shift log 0.5, you get 3.16227766. So you see that class, you get two values. The first value of power, the second value of power. Then if you want to solve the equation, 0 dBm plus 5 dBm, so you have to add power first in terms of power. 1 milli plus 3.1623 milliwatt. So you get 4.1623 milliwatt total. Okay, total. Then convert back into dBm. Okay, so that means this is 10 log, okay, the power 4.1623 multiplied with 10 power of minus 3 divided with reference 1 milli. Okay, so you get this one, 6.193. And remember, the unit is dBm. Okay, so dBm cannot be calculated directly. Okay, another one, 0 dBm and 0 dBW. So this is dBm in milliwatt and in watt. You cannot directly plus. You cannot directly add both of it. You have to convert into power first. Okay. So 0 dBm, if you convert into power, okay, so antilog of 0, you're going to get 1. And the unit is milliwatt. Another one, okay, so this is value number 1. Another one is 0 dBW. If you convert into power, it would becomes antilog of 0. Okay, antilog of 0, you get 1. But now the unit is watt. Okay, why watt? Because this is dBW. So you get watt. So now you get the second value of power. Okay, so therefore 0 dBW, 0 dBm plus 0 dBW, you have to add both of the power, 1 milliwatt plus 1 watt. 1 watt is 1000 milli. So therefore you get 1001 milliwatt. Okay, and you can convert back into decibel. Okay, so therefore 10 log of 1001 milliwatt, you divide with the reference 1 milli. So this is actually 10 log 1001 times 10 power of minus 3 divide with reference 1 milli. So you get the value. Okay, the value is 30.0043, but the unit is dBm. Okay, and if you want to convert into dBW, what you can do is 10 log 1001 milli, the power, divide with reference 1. So you're gonna get how much? If you see 10 log 1001 milli, okay, so you're gonna get 4.34 times 10 power of 3. So this is actually 4.34 times 10 power of minus 3 dBW, because the reference is 1 milli. Sorry, the reference is 1. Uh, so you see that class, the difference in terms of value is based on the reference value, the reference value. The reference value for 30 dBm, I use a 1 milli, and the reference value for 0.0043 is 1. Okay, so you see that the reference is 1. Okay, so that's why you get dBm and dBW. Clear? Do you understand? Can you follow my explanation?
Yes.
Okay.
Doktor.
Boleh Ada soalan ke? Is there any question? So if there's no question, uh, I will go back to the last example. Okay, the last example. Okay, if you see the last example, uh, for a three-stage system with an input power 20 dBm, minus 20 dBm, and power gains of three stages are 13 dB, 16 dB, and minus 6 dB. Determine the output power. Determine the output power in dBm and also in in milliwatt. So class, if you get this kind of question, I would love to suggest you to draw. Okay, so you are given three stage of a system. So the three stage here, if you see that it is combined of amplifier and also a loss stage. So if you see from here, the first one, okay, A1, is equal to 13 dB. Okay, it is an amplifier, it is a gain. Okay, as we have learned previously that minus decibel would be a losses. And then the second one, okay, the second one, A2 is equal to 16 dB. Okay, and sorry, so I rewrite the key. So, and the last one, okay, is a losses where A3 is equal to minus 6. Okay, and then you are given V in, sorry, P in. So you are given a P in equal to minus 20 dBm. Okay, and you want to find how much is the value of P out. We don't know. Okay, we don't know the value of P out. How much? Okay, so what you can do here for the first question, okay, so what I can do is I can find the total A. So the total A. So first of all, maybe what we can do here is to find the total A. A total. Okay, wait, A total in decibel. Eh, So I can write over here A total in decibel. So this is A1 in dB plus A2 in dB plus A3 in dB. Ah, do you see the difference? Previously, so this is actually equivalent to so A1. Okay, this is class. This is actually A3 8T equal to A1 times A2 times A3. Same. Okay, if you do like this is for unitless parameter. Okay, so remember a multiplication process for a unitless parameter is equal to addition process in decibel. Okay, so let me do this. So I will, so you see that calculation in decibel is much easy. Okay, so what I can do is like this. So 13 dB plus 16 dB minus 6 dB. Okay, so this is gonna be 23. So this is 10 plus 13, so 23 dB. Okay, so this is the A total. And if you want to find the P out, okay, so P out class, if you want to try to find, if you want to check the value, you can check on your own about this. So you see that A1 is actually 13 dB. And it is also, if you do anti-log class, anti-log of 1.3. I just want to show you. So this is actually 19.953. 953. Okay. You can try use your calculator. A2 is equal to 16 dB, right? 16 dB. So this is if you do anti-log of 1.6, you get 39.811. Okay, A3 is actually minus 6 dB. Okay, so this is actually anti-log of 0.6. Anti-logs of minus 0.6. So you can get 0.2512. Okay, so if you multiplied A1, so A total, if you do A1 multiplied with A2 multiplied with A3, how much you get? You're gonna get 19.953 multiplied with 39.811 multiplied with 0.2512. So you're gonna get 199.540. Okay, and if you convert this into decibel, 10 log 199.54, so you're gonna get 23. So I just want to prove it to you that it is the same method. Okay, so for the first question, okay, for the first question, so this is p p out in dBm, okay, is equal to A total in dB plus P in dBm. Okay, so you see that the value here dBm should be equal to here dBm. Okay, so if this is dB, I repeat, class, if this is dB, if this is dBW, this is should be dBW. Okay, if P out in dB micro, that means this is should be dB micro. Okay, so now our question is about dBm. So dBm. Okay, so this is actually similar like this, class. This is actually P out. If I want to do in terms of power, that means this is A total multiplied with P in. Similar with this, but I cannot write in terms of multiplication. So if it is in terms of decibel, we have to make it as plus and minus. So this is equal to 23 dB plus, so this is minus, so plus with minus 20 dBm. Okay, so this is actually 23 minus 20. So you're gonna get 23 minus 20, you're gonna get 3. So you just need to subtract 23 minus 20, so you get 3. But the unit is dBm. Okay, the unit is dBm. And if you want to try the next question, the next question you can also do like this. So minus 20, okay, so P out in milliwatt. Okay, P out in milliwatt, so I guess, okay, is equal to A total multiplied with P in milliwatt. How much is P in? So P in is equal to anti-log. So P in is equal to anti-log of 10 anti-log of minus 2. Okay, so I get this one is equal to, remember class 20, so maybe I do it like this. Sorry. So 10 log of power in milliwatt is equal to minus 20 dBm. Okay, minus 20 dBm. So power in milliwatt. So this is anti-log of minus 2. Anti-log of minus 2. So I get 0.01. So this is actually 0.01. The unit is milliwatt. Okay. You can try on your own. Okay. So therefore, this one is A total, we already get 199.540. So 199.54 multiplied with P in that we have calculated. Okay, anti-log of 20 minus 20 dBm. You get 0.01 milliwatt. Okay, so this would become 199.54 times 0.01 milli. So you get 1.99, 1.9, sorry, 199.54 times 0.01. So this is 1.9954 and 954 milliwatt. Okay, and this is the answer. Is it true? Is it true? So what you can do if you want to check, class, if you want to check. So this is 10 log. I just want to check the answer. This is the answer. I just want to check whether the answer is correct or not. So 10 log of 1.9954 milliwatt. Okay, milliwatt is 10 power of minus 3 divide with 1 milli. Reference, how much would I get? Okay, so uh, 10 log 1.9954 milli and milli, so cancel. So 1.9954, I get 3.00. So this is actually 3, okay, 0.000, and the unit is dBm. So the same, right? Same as the first answer, the first question. So my answer for the second question is correct. Okay. Class, can you follow my explanation?
Yes,
Yes,
doctor.
doctor.
Okay. I think that's it for now. That's it for now. Before we take the attendance, I just want to give you brief explanation about our project. Okay. So I will put this project instruction in the author today. Okay. But I just want to give you briefing of the first task. Okay. So class, remember that your project consists of 30%. Okay, and it is divided into two tasks. Okay, the first one is radio frequency exploration, 5%, and the other one is FM transmitter and receiver prototype. Okay, so the second task, you have to develop a transceiver prototype. The marks would be 25%. Okay, so the first task, you can start do the first task after Hari Raya. Okay, when you already come to campus physically, then you can start do the first task. Okay, so the first task, I just want to briefly explain to you. So now we are week second. Week second, I give you the briefing. And then next week is Hari Raya. So I just put it here, group discussion. You can always discuss through the WhatsApp group. Then after Hari Raya, you can start do you can execute the task one. And on week 5, you can submit the task one through the author. So task one, if you see from here, as a radio frequency RF engineer, you need to design a communication system at UTHM. To design a suitable communication system, first you need to identify the available radio frequency in the designated area. Okay, you should own a radio receiver. Radio receiver, what is this? You can use your mobile phone, you can use your car radio, or if you have a radio, mobile radio, you can tune to the specific frequency. Okay, either physical radio receiver or radio software on your mobile phone. So I believe you have your own radio, FM radio. If you normally listen to the radio in your car, you can try use your car, or if you have a software for the radio software, you can use your mobile phone as well. Okay. So what you need to do with your group members, okay, you have to go to a certain places. Okay, group one, go to the QA building. Group 2 to the library, Group 3 G1, Group 4 Dataran Anggrek, Dataran Penyu, and Group 5 to Masjid Sultan Ibrahim. Okay, so you have to browse through the FM frequency band, FM frequency band between 88 until 108, and also the AM frequency band. Okay, and identify the frequencies that contain radio station program. Okay, you have to tune one by one, and list all the available radio station. Okay, list all the available radio station. Okay, for example, 104.5 megahertz is the era FM. Okay, 88.9 megahertz is the Surya FM, and we have Hot FM, Johor FM, and etc. So you have to list all the frequencies used by the radio station. Okay, in both of these, FM radio and also AM frequency band. Okay, and you need to list down. Okay, you need to list down. For example, radio 104. For example, for FM 104.5. So this is era FM. Okay, and you can give some remarks. For example, you don't know what is the radio station of this. Okay, you haven't heard about this, so you can just write here. So this is a Malay radio station, Malay language radio station, or maybe it is an Arabic radio station, or maybe Chinese radio station, or Indian radio station, Indian language, sorry, Tamil language radio station. So uh, you can just give the remarks if you don't know what's the radio station or what's the program over here. Okay, so you can take a group picture at the given location. When you go to that location, okay, these 5 location, you have to take each group only one location. Each group only one location. So you have to take pictures, and then at the end of the activities, you need to write a group reflection. What's the new knowledge that you have learned from this assignment? Okay, so for the first task, what you need to do is actually a short report, a short report of the available frequency band. What you need to write in the report is the group number, the group member's name, the location that you go, the date and time. So you can go to the location not only once, you can go a few times. Okay, within one day you can go 2 or 3 times, in the morning or at night. Okay, or maybe another different day. I suggest don't go only once. Okay, sometimes the radio station only available at night, but not in the morning. Sometimes the radio station only available in the morning, but not at the night. Okay, so you have to go to the place, to the given place, more than once. Okay, and then type of receiver that you use for this assignment, for example, car radio or mobile phone radio. Okay, and list the use frequencies, by the radio station. Okay, you have to browse through one by one until you can list all the frequencies. Okay, and then you can submit the short report through the author, due date 18th of April. Okay, through the author. Okay, so please read this task one first. Okay, today I will put in the author. Okay, the next task you can read later. Okay, the next task two is will be explained later after Hari Raya. Okay, what you can do now is try to read and understand. Then I will put in the author. Okay, so that's why I asked you to create a WhatsApp group with your group members so that you can communicate with them. Okay, so now you can take your attendance. Okay, class, you can take your attendance. Sorry, then now it's 11 o'clock, so you should go to another class, in my opinion. Okay, so open your QR code reader. Okay, open your SMAP apps to record the attendance. So after you take the attendance, then you can go to anywhere you like. Okay, and that's all for today's class. So see you again next week. For next week, I will make a replacement class on Saturday again, because Tuesday would be the Idul Fitri holiday. Okay, on Tuesday is the Idul Fitri holiday, and I will make a replacement class on Saturday. Okay, so that's all for today. So selamat Hari Raya, Idul Fitri to all of you, and happy holiday. Okay,
Sir, sir,
yeah, yeah,
saya tak boleh scan.
tak dengar.
Saya tak boleh scan.
Kenapa?
Saya punya, tak tahu, dia problem.
Nama siapa ya?
Syazwani.
Nama?
Nur Syazwani.
Nur Syazwani. Mana Nur Syazwani? Saya ni Nur Syazwani binti Ramli.
Ya.
Okey, dah.
Saya kat doktor.
Nama
Nombor
siapa?
Muhammad Hasanuddin.
Try scan dulu boleh?
Saya cuba tak dapat tadi.
Saya pun
Siapa
tak
yang
boleh
boleh
dapat
scan dulu? Try scan dulu. Boleh tak? Okey, siapa yang tak dapat nak scan? Siapa? Bagi nama?
Saya Muhammad Azim Haikal.
Muhammad Azim Haikal. Okey, done.
Terima kasih doktor.
Okey, sama. Siapa lagi belum scan? Any more?
Saya doktor.
Okey, nama?
Nur Asia Atira.
Nur Asia Atira. Okey, done.
Terima kasih doktor.
Okey,
Saya Dr. Muhammad Amiruddin.
Amiruddin. Okey, done. Lagi siapa? Ni Hafiz datang tak? Okey, siapa yang dah scan boleh keluar.
Terima kasih doktor.
Okey,
Thank you,
sama.
Doctor.
Okay,
Thank you,
welcome.
Doctor.
Okay, welcome. Hafiz mana Hafiz? Hafiz ada tak? Hafiz. Oh, Hafiz dah tak ada. Okay, Hafiz dah ada. So stop recording.